Alright, so we're in electric closet 1202, right off of the service elevators. This is where we have the Phoenix PCI and the AIRCUITY IMS. So the Phoenix PCI has two blue wires coming in. That is your lawn communication coming from east side and west side. The lights that are listed on that troubleshooting guide, these are where all the lights are. So these are your two lawn modules. If they still have comm, they should be blinking like this. That's spelled out on there. It also has primary port, which is labeled with the IP address, and then the service port. So if this cable were to get moved over to the wrong port, it could be plugged in and you would have lights, but it wouldn't be communicating with the graphics. This is where your power is coming in for the PCI. This other yellow wire is just a BACnet MSTP communication that goes from the PCI to the APMs, the active pressure monitors that are outside of the room, and that's just for being able to monitor those. We also have our AIRCUITY IMS. IMS is the information management system. It's basically the brains for the AIRCUITY. So it's what's telling our sensor suite what to do. It's what is reporting out once we have an internet connection. It'll be what's reported to myaircuity.com. If it's ever desired to have values from AIRCUITY read on the graphics, we can pull up. Same thing. There's two Ethernet ports that we can have both. Transformers here are the transformers for AIRCUITY. Transformers for Phoenix are outside of this electric closet in the hallway, kind of over top of this door and over top of the elevators. And the other transformers for Phoenix are on the other side of the building in the other electric closet. You have electric closet on the other end, and they are, as soon as you go in the door, you have them up, and Gray Voice has those labeled what valves are operating on. So if you ever have a power issue, that's where to look for your 24 volts. It's either going to be outside this door or in that next electric closet. The red things that you see on the line communication are in the line resistors. So there's only going to be 4 of those in the building. You have 2 here, and then there's 2, one on the end for each of the lines. So most of the valves you go to won't have those. So if you see that, that's why it is. Anything else you go to, all of the line communication is daisy chain. So most things you go to, you'll have a blue in and a blue out. Our AIRCUITY system is over here. This is our sensor suite. We call it SST. This is where we come and we change out sensors and replace them with recalibrated sensors. It has two green tubings. We call them our 2 limbs, the limb A and the limb B. So the way that the AIRCUITY system is working, we have the pumps up there. One pump is always running. If the pump ever fails, there is a pump control module in here that is sensing to make sure that there's enough pressure. If it ever loses that vacuum, it will switch over so that the second outlet will be powered instead of the first one. You'll still have a pump running all the time, and then once we have the internet connection, AIRCUITY will also know about that, and they'll start the RMA process for getting a new pump out here. The AIRCUITY always has a pump running. There's a series of air data routers going down the main hallway here. And those routers basically just have a series of solenoids in them. 4 solenoids for 4 test areas on each air data router. As you hear this, the noise kind of changing. What it's doing is the AIRCUITY system is going and it's saying, okay, room 1, I want to pull a packet of air. And so it opens up the series of solenoids to pull a packet of air from room 1. It will then run at a transport speed. So that's why you hear the volume changing. It's going to run at a transport speed to pull enough air through those the green tubing, through that solenoid, to get air where it's just pulling from room 1 now. Once it's now cleared out the old air that was in that line, it switches over to a low flow mode, and it runs that packet of air through these series of sensors. And those sensors sample that air. Once it has the sample, it switches over. The solenoid that was open for room 1 closes down. The solenoid for room 2 opens up. It goes to high flow mode again. It purges that air out of the line again, and now it's going to switch back to sensor mode. So it's constantly going through a cycle and sampling it. Every time it finishes, it starts back at the first one. Sensors that we have in here, we have CO2, carbon dioxide, we have dew point. So we have dew point, we can calculate relative humidity, but we don't have an actual relative humidity sensor. It's a dew point sensor and then calculate a relative humidity. We have temperature sensors, so in that green tubing that we looked at downstairs, there's built-in wiring wrapped up in that, and then the sensor has an RTD sensor. So we are monitoring the temperature there, and that's how we're between the dew point sensor and the temperature.
Return temperature differential.
Yep. So we have TVOCs, which we talked about a little bit. That's total volatile organic compounds. That'll show different chemicals, and it indirectly shows formaldehyde. So that's one of the reasons that you would have it any place like the morgue.
Metal quality.
Yep. Well, right now most of those are still set as constant volume for the design.
Right, but when it's up and running, then
Well, it has the ability to, if they ever design that for a higher airflow, it's the hard wire's all there and everything's there for being able to increase that. And particles. So it's sensing small particles as well. So the way that it would work for being able to increase your indoor air quality command, the IAQ command that you have in Phoenix, is sampling your different rooms, and then there's one supply air sensor. So instead of just saying, I want it to be less than 700 parts per million on my CO2, or whatever the different parameters. You have different parameters for TVOC. Instead of just saying this is what I want for the CO2 specifically, you can compare it to the supplier. So it's saying we look at what the difference is between the two. So one of the advantages to doing it that way and having it all go through the same sensors is if you ever start to get a sensor drift, the reference and the space are both drifting the same. You will never have them drifting different. And then every 6 months we come out and we replace these sensors with calibrated sensors. We get sensors shipped out from the factory that are calibrated, plug them in here, ship back the old ones for them to get recalibrated. So they're constantly getting recalibrated. So all the sensors are here. Everything else is just a sample point. You got a question on that?
the air, where does the air go? It's being sampled.
What's that?
Where does the air go after it's been sampled?
After the air is being sampled?
Does it constantly just get
Yeah.
like a closed loop?
Yeah. Well, it's not
So
really
you sample
close
from
loop.
here, and then, well, yeah, so say it's got formaldehyde. Where does that air go? Where goes it get dumped to? And then that little bit of air that's being picked up.
Right
Where does
now,
that go? Yeah, where does that get
right
discharged?
now, AIRCUITY, right now it's just up at the, get discharged up here. So it can get tubes to exhaust. That's something that we have the ability to do, but right now it's just discharged here. Because it's just.
You know what I'm speaking of?
I know what you're saying. And there's certainly times that they have us get it to exhaust.
Right, okay.
Is there maintenance that needs to be done, regular, anything to this?
There's nothing that you need to do with this. So that's all the contract that goes either, I don't know what it is with Drexel, but it's either a contract with TKO or with AIRCUITY, and then we're sub to AIRCUITY. So if there's ever an issue with this, you call us and we come out and take care of it.
Well, you come here yearly?
We come here twice a year anyway,
Twice a year.
and
change.
yep, to change out the sensors, and if
Recalibrate.
there's a failed pump, but we are not recalibrating, I'm just putting in a new calibrated sensor.
Okay.
So I don't do the calibration here, they ship out calibrated sensors,
Calibrated.
and these do unplug, plug in the new ones,
Plug and play.
make sure that there's no leaks, because we can tell if we can still do a leak test to make sure there's no leaks in the system. And then we.
You said if there's a compressor failure, you automatically come out and change. Did you monitor this stuff?
Once there's an internet connection, if there's not an internet connection, when I come out and we change the sensors, we test that both pumps are running. So twice a year we're checking it anyway, and if one has failed and we're over to the backup, then we start the RMA process.
If you have an internet connection, you're.
If you have an internet connection.
You know the compressor failure, you're automatically just coming out and building.
Yep. Once we have that internet connection, AIRCUITY contacts us and says, we have a pump failure in whatever building, we need somebody to go and check it
Without
out.
it doing this, notifying you, anybody, you're notifying you, it's automatically set.
Yep. And I don't know who our contact would be when we go through Mark, but whenever we get in here, we'll have to twice a year. Would I be contacting you? Would I be contacting Martin?
No, you guys are handling this. From what I understand, I don't know. See, that's the thing. We'll find out.
We'll find out. But that's something that twice a year still needs to get in there.
What our,
Yep.
position is here on the farm.
So that's basically it. We can walk and look at a fume hood, and we'll look at one of the pressure monitors outside of the door. If you want, we can walk over by the other electric closet just to show you where those
Yeah.
transformers are.
Look at that, yeah.
Yep.
And then we can go to the,
Okay.
look at that bench here. So